Hi guys, it's Victor with the solution to the problem Codeforces 1453b. This is a rather easy division 2 problem. We rate the complexity of this problem as 2 out of 5 and its elegance as 4 out of 5. The problem can be rephrased as follows. We have an array of n integer numbers and can perform incremental or decremental operations on arbitrary suffixes of this array, by increasing or decreasing all the elements in the suffix by 1 simultaneously. We need to find the minimal number of operations to make all the elements in the array equal. A special note here is before starting with our operations, we can replace an arbitrary element in the array with any value. To come up with a solution, let's try to deal with the optimal sequence of suffix operations first, leaving the initial replacement of one element to the end. Let's start with an example here. For a given array, an optimal solution can be like this. With 3 operations in total. Another example. Let's say there is an optimal target array and there is an optimal sequence of operations yielding the answer. As the order of the operations doesn't affect the final answer, because the operations are commutative, we can sort the operations by the length of the suffix that these operations alter. We see here that the operations incrementally flatten the suffix, starting from a flat suffix of 1 element, a flat suffix of 2 elements, 3 elements, and etc. Now that we know that operations in an optimal solution can be ordered in such a way that the suffix of the array incrementally flattens, we can build a solution. In our last example, we want to flatten the last 2 elements firstly. We can do so only by adding 1s to the last element 3 times. Next, we want to flatten the last 3 elements. It's possible only by subtracting 1 from the last 2 elements twice. We cannot do it later when we apply longer operations. Now that the suffix of the array is flat, we want to flatten the whole array. Again, it's possible only by adding 1 to the suffix of 3 elements. We can see now that the minimal number of operations is the sum of the modulus of differences on the source array. Let's now see how we can improve the solution with the power of altering 1 element before the operations. As the answer to the problem is the sum of the differences, altering 1 element a of I may affect 2 differences with a of I plus 1 and a of I minus 1 if a of 1 is not a border element. It's good to illustrate the numbers on a numeric axis. To minimize the sum, we need to place the element a of I inside the range a of I minus 1 and a of I plus 1. As there are many solutions, we can always make the element a of I equal to a of I minus 1, which simplifies the code for us. Now we iterate across all of the elements and calculate the sum of the differences, selecting the element with the maximal result. This will be our initial element to modify as a special case. Let's consider a possible C++ implementation. First, we read the source array. Next, we calculate the number of operations as a sum of the modulus of the adjacent differences on the source array. Finally, we calculate the answer improvement by excluding every element individually from the sum and process the border elements as a special case. Let's take a moment here and enjoy the elegance of this solution. This solution is available as a GitHub link in the description for this video. Please subscribe and get notifications on interesting programming problems, and also please grow as a strong developer every day. Stay tuned.